Hello dear students, welcome to YourPedia. Today I am going to discuss famous circuits in interviews. So these are the circuits asked previously many a times in many interviews. So combination of source and elements, different sources with different elements. So these two are the most commonly asked circuits in interviews, especially BARC, ISRO and DRDO interviews. Many times these questions were asked. What is the question here? So there is a DC voltage source. This is DC voltage source. There is a capacitor. Yes, whose units are in farads. Yes, and there is one more capacitor, one more circuit. Okay, this is second circuit. Now the interviewer will give this circuit to you. Yes, and he says that switch got closed at a t is equal to 0 and the initial conditions of the capacitor are 0. Now, does this combination is practically possible? Does this combination is practically possible, or what are the limitations or what are the disadvantages of this combination, connecting a voltage source directly in series with a capacitor? Capacitor is ideal, voltage source is also ideal. There is no internal resistance for voltage source and the capacitor is also ideal. Now here we all know that capacitor does not allow sudden change in its voltage. If we close this capacitor at t is equal to 0, then what is Vc of t? Yes, what is Vc of t? Vc of t is equal to V at t is equal to 0. Instead, I'll write here it as not Vc of t, Vc of 0 in fact. Vc of 0 is equal to V according to, I can say, KVL. In the loop voltage must be, see, these two are parallel, voltage must be same. That way we can understand. This voltage V volts and that voltage must appear here. But for sudden change of voltage, capacitor behaves as a short circuit. Why? First of all, let's get clarity one by one. We all know that capacitor does not allow sudden change in its voltage. If you say this statement to the interviewer immediately will ask, why capacitor does not allow sudden change in its voltage? This will be the first question. Yes, question is, why capacitor doesn't allow sudden changes in its voltage. Why it is so? Why? Yes, so many students will come from formula. Yes, I'll discuss all the ways. Yes, yeah, V equal to, or let's take I is equal to C dVc of t by dt. Current through a capacitor is equal to C into derivative of voltage across capacitor by dt. Now, sudden change, sudden means, yes, sudden change means this dt is tending towards 0. Then how much current I require to get sudden change of voltage across capacitor is infinite amperes is required, which is not possible practically. Sir, yes, it is not possible to supply infinite amount of amperes so that sudden change of voltage across capacitor doesn't take place. Or if I want sudden change of voltage across capacitor, I have to supply infinite amperes of current to the capacitor, which is practically not possible. Accepted. This is one way of answering, formula based answering. Okay. So another the best method of, or the best way of answering this question is this one. That is, see, whatever may be the energy storage element, capacitor, inductor, whatever it is, energy will not change suddenly from physics. Suppose there is a fan running in the room. If you switch off the fan, does the fan will stop suddenly or it will take some time? It will take some time. Why? Because many people will answer it as an inertia. No. Fan is having some kinetic energy stored in its rotor body. For that energy to reduce to 0, it will take some time. One more example, I give physics example. Suppose there is a cup of coffee having thermal energy, some temperature. Does that temperature will become to normal room temperature within 0 time? No, it will take some time. Why? Because it is having some thermal energy. For that energy to decrease, it will take some time. Or one more example, You are running very fastly. If I ask you to stop suddenly, will you stop? No. Sudden means within zero time. Please do understand the meaning of sudden. Okay, will you stop? No. Why? Because your body attains some kinetic energy. Yes, your body is having some velocity. Yes, having velocity and mass means you have some kinetic energy, that is half mv square. For that kinetic energy to become equal to zero, it will take some time. Or see, the very simple statement from physics is, for energy to either increase or decrease will take some time, but that is not going to happen suddenly for energy. So the global statement is, energy will not change. Yes, this is the global statement. I'm putting star for this one because if you understand this one, transient analysis of networks is going to be damn easy for you. Okay, energy will not change suddenly. Any energy, kinetic energy or potential energy or thermal energy or electrical energy or magnetic energy, whatever it is, it will not change suddenly. Now sir, all of a sudden why we are discussing about energy? Yes, what is energy of a capacitor? Energy, see, the first statement here is, I'll take like this. So we understood that energy will not change suddenly for any energy storage element. Okay, so capacitor is also one of the energy storage element. I can write here that capacitor does not allow, yes, capacitor does not allow sudden change in its energy. Sudden change in its energy. Capacitor does not allow sudden change in its energy. Now, if you look at the energy of a capacitor, half C V square. If you look at here, half constant C constant, energy of a capacitor is directly proportional to V square. We know that this will not change suddenly, therefore voltage also will not change suddenly. Energy of a capacitor will not change suddenly. Voltage, energy is going to depend upon voltage across capacitor. Fortunately or unfortunately, that's why voltage across capacitor will not change suddenly. If you take inductor in the same grounds, what is energy? Half Li square. Yeah, what is the first statement? Energy of a inductor will not change suddenly. Inductor does not allow sudden change in its energy. Okay, energy will not change. But energy of inductor, fortunately or unfortunately, is going to depend on current. That's why there is a statement that inductor does not allow sudden change in its current. But inductor does not allow sudden change in its energy. First, energy of an inductor is going to depend upon current. As energy is not changing suddenly, current also will not change suddenly. So this is the answer. It's a beautiful analysis. Come back. Now, we need infinite amperes of current here. Here, if you observe, now, if I switch on this circuit at t is equal to 0, before t is equal to 0, see, at t is equal to 0 minus, let me write that one here. Yeah. At t is equal to 0 minus means just before closing the switch. What is Vc of 0 minus? That is 0. Yes. At t is equal to 0 plus, according to this parallel, according to KVL, voltage must be, see, this voltage must drop here, right? Now, Vc of 0 plus should be how much it is? It should be V. But what capacitor is saying? I don't allow sudden change of my voltage. Sudden means how much? Within 0 time. Yeah, how much is the difference between 0 minus and 0 plus? 0. 0 minus means just before closing the switch. There is a lot of difference between before closing, just before closing. Before closing means, see, I'll tell you one example. Before 9 o'clock means it may be 8 o'clock, 6 o'clock, 7 o'clock or 5 o'clock or yesterday, day before yesterday. There may be anything. Before 9 o'clock means. Just before 9 o'clock means 8 o'clock, 59th minute, 59th second. After that, what is the highest fraction you can take? Till means just, see, magnitude wise, just before 9 and 9 both are same. But what is the difference between 9 and just before 9? At 9, we are closing the switch. Just before 9, switch is not completely closed. See, three things are very important to understand this transients topic. That is, just before closing, closed, just after closing. All three are magnitude wise same. But what is the difference? What is the difference? Just before closing means switch is not yet closed. Just after closing means switch is already closed. At the time of closing, switch is neither in closed position or in open position. We are unable to comment at that point during the close, right? So it is saying, see, this parallel combination of voltage source and capacitor, according to KVL, is saying that we want this, but capacitor saying that I don't allow sudden change of voltage. Yeah, 0 minus to 0 plus the time difference is 0. Yes, sir. I don't allow sudden change of voltage or sudden change of energy. Primarily sudden change of energy, but a sudden change of voltage. From the formula we already seen and concept also. Yes. Now what will happen? See, capacitor will behave as a short circuit. Capacitor will behave as a short circuit. Why? Because it is not going to allow sudden change of voltage. Means what was the previous voltage in the capacitor? 0. Before closing the switch, the capacitor was initially not charged. Voltage is 0. 0 voltage means short circuit. Even just after closing the switch, I am talking about just after closing the switch, capacitor does not allow. See, see, according to parallel combination, it is to be this one, but it will not happen. It will be 0 volts only. If it is 0 means what? It is a short circuit. It is a short circuit. We are short circuit a voltage source. Then how much is the current that is flowing? I. So I can write here I is equal to V by 0 infinite amperes. Means a spark will happen at the switch and capacitor and voltage source both will damage. I can say not spark will happen at switch. Why? Because we are not opening the switch, we are closing the switch. We closed it, huge amount of current will flow, and suppose if this is a DC machine, if it is a DC generator, winding of the generator will damage. Why? Because huge amount of current is flowing, because of which heat will develop. That heat, if it exceeds the limits, then winding is going to damage, insulation will damage. So this combination practically, yes, we should avoid this type of combination practically. Okay, we should avoid this type of combination practically. Let's go for the next combination. Sir, connecting a DC voltage source to a capacitor and closing the switch at t is equal to 0 is creating a lot of problems. Then why can't we connect this way? Yes, let's see whether we can do this way or not. Many students will say that, sir, it is very happy we can connect like this. This is also not allowed. Sir, why? Capacitor will allow sudden change of current? Yes, capacitor will allow sudden change of current. Inductor will allow sudden change of voltage. The problem for capacitor is with voltage, the problem for inductor is with current. Because energy of capacitor depends upon voltage, energy of inductor depends upon current. But capacitor current, it will allow. Inductor sudden change of voltage, it will allow. Then what is the problem here? Okay, see, at a t is equal to 0, it is okay, happy, no problem. Now, what is voltage across capacitor? What is voltage across capacitor? Vc of t is equal to 1 by c integral I of t dt, but that I of t is what? It is a DC current. It is a DC current, I dt, right? I dt. So Vc of t is equal to I by c, take the limits from 0 to t, I by c, I is a DC value, take I outside, 0 to t dt. Let's do in the next page, ma. Yes, fine, I'll add a page here. Yeah, what is Vc of t, ma? Vc of t is equal to I by c integral 0 to t dt. What we are going to get? Vc of t is equal to I by c into t. Observe it carefully, ma. Observe it carefully. Yes. Now, if you remain this switch closed for a long time, as t is increasing, Vc of t will increase. After some time, it is going to exceed the safe limits of voltage. Permanently, you can't make this switch closed. You can close that switch for some particular amount of time only. That depends on the withstanding voltage of this capacitor. Suppose if this capacitor, let's take some values. Let's take I is equal to 1, C is also equal to 1. Okay. Now the withstanding voltage of capacitor is suppose say 5 volts. I can close that switch up to 5 seconds only. So this combination is also, see, This combination is not creating any trouble if you are opening the switch after some time. That time we have to calculate depending on the highest withstanding voltage of this capacitor. Yes, so this way circuits will be given and they'll ask too many cross questions in interviews. It's a very good discussion in interviews like BARC, DRDO and ISRO. They will ask many cross questions, and if you stuck at some place, they will help you also in the interviews. See, when you are studying a subject, you cross question yourself. If this happens, what will happen? If that happens, what will happen? In this way, if you think, definitely you'll succeed in interviews. Thank you.